So in this lesson, we'll take a look at some miscellaneous items as it relates to loops, along with the idea of the nested loops. So if we recall from our previous experience, we can certainly use a loop to keep a running total of values as they're being entered. And so a standard algorithm, to accumulate value is this idea of grabbing what was previously stored in memory and adding it on to the next value and storing it back in there. So we can sum a series. So here, sum is equal to 0, num is equal to 1. So as long as 1 is less than or equal to 10, so they let sum plus equal sum. Now remember, sum plus equal sum is the same as sum is equal to sum plus 1, or num. And so first time through, it's going to take 0 plus 1 and store 1 into memory, then 1 plus the value of num, which is 2. So it's going to store 3 in memory. And then 3 plus 3, which is going to give us 6. And then 6 plus 4, which is going to give us 10, and so on. And so then this will give us the sum of the numbers from 1 to 10 is, and give us that value, and using that incrementer as it's going up through. I can do this in a for loop. I can do this in a do while loop. One thing to note, that all three loops are interchangeable. I can write any loop into any one of the three structures. Some are just better suited for others. The user could have entered, instead of using the counter here in the while loop, we could have asked the user to enter that value. And so we could, num could be a entered value, and so we could sum that series from there. So that's just a review of an idea that we already studied previously in our past experience. So here they have a for loop as an example. And so we have days, we have a total. So for how many days do you have sales figures for? And so the user's going to indicate how many days that they want. And I probably would use a while loop and maybe a terminator, a sentinel value, but this one asks for it. And again, I can use a variable here in a for loop. Again, they're interchangeable. And so this will ask the user to enter the sales for day 1. And so the user enters the sales, and so this will keep a running total of the sales entered by the user. So we can see here that for day 1 of the loop, they entered 5 days. They entered the 489.32, and then it increments. So since 2 is less than 5, it will ask for more input. 3 then less than 5, ask for more input, and so on. And so they were able to accumulate the total, a running total. And once the loop terminated, then we can see that using currency format, it printed out the total to the screen. So a sentinel value is a flag. Another word I would use is a flag. And so it's something that we would use to, that the user maybe might use to enter, to flag, to say, hey, I'm done. Maybe like a negative number, because that's not part of the set, would be an example of a sentinel flag. If I'm putting in strings, the idea of done, instead of maybe a salesman's name. Even putting in no is in itself a sentinel flag to indicate that I want to terminate. But it would be a special value that cannot be confused with the data that is being entered, and we might use that to terminate our looping structure. So for example, here game is equal to 1, we have points, and then total is equal to 0. Enter the number of points your team has earned so far in the season, then enter -1 when finished. So this one is going to test, as long as points is not equal to -1, it's going to continue to ask the user to input total points. And so the idea here, it's incrementing total points that the user entered. It's also tallying the number of games that, so the number of iterations, game indicates the number of iterations that the loop went through. And so then when they're done, it prints out the total of the points earned. We can find the average per game because it also kept track of the number of iterations that the loop went through, so the number of games. So here the user entered for game 1, 2, 3, 4, and 5, 7, 9, 4, 6, and 8. And so total points was 34, but it terminated as soon as the user entered the sentinel flag of -1. So deciding which loop to use, the while loop is a conditional pretest loop. So it is one if you don't know the number of iterations that you want and you want to make sure that you are validating a value before the loop itself executes. Okay, maybe in this case, reading a list of data terminated by a sentinel value would be a good example. The do while loop is a conditional post-test loop. So if I know I want it to iterate at least once, but it may never iterate again, the do while loop is a good structure. Again, I may not know the number of iterations that I want, but I know at least will execute once. The example previously given was using it for a menu. You know, the idea that I can choose off the menu as to whether or not I want to, you know, one option over another, but I can have the option to quit. The for loop in itself is a pretest loop. It's a built-in initialization, testing, and updating structure. So if I know the number of iterations that I want, that's when a for loop is best to be used. But what I want to say is that they are all interchangeable. I can write a for loop rather than a while loop, or a do while loop. I can interchange the looping structure. Nested loops. We've studied nested loops in our previous experience. Little bit tricky, we know our nested loops to be. A nested loop is a loop that is embedded inside of another loop. Okay, in the past was the idea that we would have for x equals, and then maybe for y equals, where we had a next y, and then our next x. So this idea that they don't overlap each other, one is embedded in the other. A nested loop is used when I need to control two values. In this case, in the example here, I'm controlling the row and the column of some structure. If I need to control, you know, the number of people and then the number of tests per person, a nested loop is that structure that I might use. So for this one, we initialize row to equal 1, and it's going to go from 1 to 3. We initialize column to be 1, and so column is also going to go from 1 to 3. And so what they're going to do is they're going to see out row times column. So for every row, the column's going to iterate 3 times. So while row is equal to 1, column is going to iterate through 1, 2, and 3. So I'm going to get 1 times 1, which is 1. I'm going to get 1 times 2, which is 2, and 1 times 3, which is 3. The inner loop fails, takes 1 line by default. Inner loop fails and it increments row to 2, but column is still going to reinitialize and execute 1, 2, and 3. So now it's going to be 2 times 1, which is 2, 2 times 2, which is 4, 2 times 3, which is 6. It is going to fail the body of the loop, and row is going to increment to 3. Column is going to reinitialize and execute from 1, 2, and 3. So 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. It fails the body of the loop, but it also will fail the outer loop, and so there it terminates. Something to note about nested loops. It will iterate the number of times that the inner and outer loop execute the product of. So 3 times 3, 3 is the number of times the outer loop executes, 3 is the number of times the inner loop executes. So we'll execute a total of 9 times, which was that 1, 2, 3, and then 4, 5, 6, 7, 8, 9 times. And this one produced for us these numbers. Now this actually produces them all in this one vertical line. All right, this is not producing it as a table. It will produce it as one long vertical line to the screen. So here we see a nested loop with a variety of things going on, more than one line executing. So we do need curly braces that are embedded inside of another for loop. So this one, students equal to 1. So as long as 1 is less than the number of students, and it's going to increment students, total is equal to 0. So this initializes the accumulator for each one. Double score, so they're going to enter a score. So the student enters a enter score for test. Test is 1. Okay, and then enter for student 1. So the user enters the score. So it's going to enter student 1, test score 1. So this is going to be a 1 and a 1 the first time. And then it's going to increment test 2. So it's going to ask for test 2 from student 1 because that was the outer loop. And then test 3 for student 1, accumulating a set of scores. Once the inner loop fails, it finds the average of the 3 test scores for student 1, prints them out, and then it increments student to 2, repeats the process for student 2, going 1, 2, 3 for student 2, finds the values for student 2, fails the inner loop, increments student to 3, and starts the process all over again for student 3. So when I'm controlling 2 elements, that's when a nested for loop, or I could nest this to be a while loop, or I can nest this to be do while loops. I can create this same structure for each of those looping structures. The inner loop goes through all repetitions for each repetition of the outer loop. All right. The inner loop repetitions complete sooner than the outer loops. Total number of repetitions for the inner loop is the product of the number of repetitions of the 2 loops. So in our last expression, now I don't know the number of students, but let's say it were 5 students with 3 tests. Then this inner loop is going to execute 15 times the product of the outer and the inner loop. I can break a loop if I want to, and I can also continue a loop. So we can use the keyword break, which we used in our switch case statements, to terminate the execution of a loop. We use it sparingly. Okay, we should only use it if no other solution presents itself. And so we will really never need to use one, not at the work that we are doing in this course. But what it will do is it will break the loop and it will terminate the loop altogether. All right, when used in an inner loop, it terminates that loop only to go back out to the outer loop. So I could actually put one in the inner loop, and we need a test condition in order to do that. I would use an if statement. If some condition is true, I might want to break the loop, and it permanently terminates the loop. Versus a continue. The keyword is continue. And a while loop or a do while loops, they go to test and repeat the loop if the test passes. For a for loop, it performs the update step, then tests, then repeats the loop if the test passes. Now, a continue will break the current iteration of the loop, but it will go up and execute the next iteration of the loop, though. But I might terminate it. Let's say, I've come upon a 0, and so I don't want to be able to divide by 0. So I can tell the loop to break that current iteration so that it can go on to the next value, skipping over a value if I wanted to, and then tell it to continue iterating the body of the loop. So the continue only breaks the current iteration of the loop, where the break will break the entire loop altogether. But we use them both sparingly.